We're going to continue with our lessons of solving systems of simultaneous equations. So far, we've been working with two variables, x and y typically, and we needed two equations with the same two variables to solve them. And we were working with solving them by a couple of different ways. We graphed them, which is good to get an overall visual for what's going on, but not very accurate. We also used the substitution method, and we used linear combination, which is sometimes known as the addition method or elimination. But today, in this lesson, what's going to be a little bit different is we're going to be working on real-life situations expressed in sentences. Actually, that's what I call them, but more commonly known as word problems. So let's start by just reading the problem, getting an idea, overall feeling for what's going on. It says, in one day, music store sold 10 guitars for a total of $4,800. Electric guitars sold for $450 each, and acoustic guitars sold for $550 each. These were the only types of guitars sold that day. How many type of each guitar were sold? So let's go back now that we kind of picturing this in our mind and read the question or read the prompt, what we're asked to find. And what we need to find out is how many of each type of guitar were sold. We need to know how many electric guitars were sold, how many acoustic guitars were sold. And so I would suggest what we do first is create some variables and then write a reminder to ourselves what those variables are representing. So in this particular solution, I'm going to let X represent the number of electric guitars that were sold that day. We're going to let Y represent the number of acoustic guitars sold that day. And then what we need to do is we need to come up with an equation that represents the situation in these words. In fact, two equations. So the first equation is going to represent how many guitars were sold. If we go back and read the problem, we're told a certain number of total, there were 10 guitars sold, but we don't know how many electric guitars and how many acoustic guitars were in that group. The other thing they're talking about in this problem is the amount of money each type of guitar costs, and the total brought in. So that would be our second equation. We need to represent the amount of sales in dollars. So our first equation is we know that the two different types of guitars, the electric, which we're representing by X, the acoustic, which we're representing with Y, added together, the sum of those was 10 because there were 10 guitars sold in total. And then for the total dollar amount, we know that there's $450, which is how much each electric guitar cost, times the number of electric guitars sold, plus $550, which is the price of one acoustic guitar, times how many acoustic guitars were sold, brought in a total of $4,800 in sales. So our task at this point is we're going to take those two equations and we need to solve them using one of the methods we have learned previously. Again, graphing is good to get a picture, but it's more accurate, and I think you guys prefer substitution or linear combination. So for this particular problem, what I'm going to do is take this top equation, the x plus y equals 10, multiply everything through by 450. So 450 times x is 450x, 450 times y is 450y, 450 times 10 is 4,500. We're going to keep that second equation as is, 450x plus 550y equals 4,800. We're going to subtract the two equations. And when we do that, 450x minus 450x is eliminated, which is why we call this sometimes the elimination method. We're eliminating one of the variables. 450y plus 550y, subtracting, sorry. 450y minus 550y is negative 100y. And 4,500 minus 4,800 is negative 300. To solve for y, we simply divide both sides by negative 100, and we find out that y is equal to 3. Now let's take that and substitute into either original equation. I recommend the first equation, seems much easier to solve. If x plus y is equal to 10, we now know that y is 3, so we're going to substitute in again. and then subtract 3 from both sides. We're going to solve, and we find out that x is equal to 7. And let's remind ourselves what that meant. X was representing how many electric guitars were sold, and then Y was representing how many acoustic guitars were sold. So that particular day, there were 7 electric guitars sold and 3 acoustic guitars sold. All right, let's take a look at our next example. A one-day pass for an amusement park costs $6 more for adults than it does for children. When 3 tickets were purchased for children and 7 were purchased for adults, the total cost for the tickets was $852. Find the cost of each adult ticket. This is a pretty typical scenario that adult tickets at amusement parks cost more than children's, but let's go back and either look for the question or what we're directed to find out. And again, this last sentence here tells us find the cost of each adult ticket. All right, so again, we're going to write this down so we keep it all straight in our mind. Let's just let X represent the cost for a children's ticket. Let's let Y represent the cost for an adult ticket. And then we're going to take equation 1 and represent a comparison of the ticket cost, because that's what we're given here. That the adult ticket costs $6 more than children's. So that'll be our first equation. Our second one, again, is going to come from the dollar amount, the total cost of the tickets, which was $852. So let's get these equations we can set up. Y, which represents the adult tickets, cost is 6 more than the children's ticket. So Y equals X plus 6 is our first equation. Second equation, there were 3 tickets purchased for children, which were X, so 3X, plus 7 tickets that were purchased for adults. And again, Y is representing the cost of an adult ticket. And if we add the amount of money spent on children's tickets and adults' tickets, that's equal to $852. So there's our 2 equations. And this particular setup is much easier to solve using the substitution method. So for substitution, I know that Y is the same thing as X plus 6. So in the other or second equation, I'm going to replace Y with X plus 6, our goal being to combine the 2 equations into one that has just one variable. So once we've done that, let's go ahead and solve for X. Let's distribute out 7 times X, 7 times 6. Continue to simplify this equation. 3X plus 7X is 10X, plus 42 is equal to $852. Subtract 42 from both sides. That gives us 10X is $810. Divide both sides by 10. And X, the cost for a child's ticket, is $81. Again, we're going to do substitution, and I would suggest we'll take this first equation, Y equals X plus 6, and replace X with the $81 cost that we found. 81 plus 6 is 87, and that is the cost of the adult tickets. So the children's tickets were $81, adults tickets, children's were 81, adults were 87. All right, our third example for this lesson, we're going to talk about cost of renting a moped at one of 2 different locations. So Joe's Moped charges a rental fee of $35 as a flat fee, plus $5 per hour or any fraction thereof. So yes, if you come in 1 minute later, you're charged for the entire hour. Sam's Moped charges a rental fee of $20 as a flat fee, but $7.50 per hour or any fraction thereof. And the question here is, when is it more cost effective to rent from Joe's Moped? And my hint is let's find out when it costs the same. So we're going to continue solving our systems of simultaneous equations. So let's go ahead and let X represent the cost per hour, Y represent the total cost for each rental service, And we're going to come up with equations like this. Joe's was a flat fee of $35 plus $5 an hour. So X represents the number of hours there. And then Y would be the total cost for renting at Joe's. Secondly, Sam's was a $20 flat fee plus $7.50 per hour. So Y is 7.5x plus 20. Those are our two equations. And we know that Y equals 5x plus 35. Y equals 7.5x plus 20. So we can just go ahead and do substitution. Since they're both equal to Y, we can set them equal to each other and solve for x. Doing so, we'll subtract 7.5x from both sides, since most students like the variable on the left. That's negative 2.5x plus 35 equals 20. Let's go ahead and subtract 35 from both sides. And we have negative 2.5x equals negative 15. Let's divide both sides by negative 2.5. And we'll find out that when x is 6 hours, the cost is the same. But let's find out what that cost is going to be. So second part of this equation, let's just take the first of the two equations, y equals 5x plus 35. Substitute in 6 for x, which is 30, and that to 35. And so after exactly 6 hours, both moped rental places charge $65. Now that doesn't answer the question. So in a word problem, it's always good after you've solved some algebraic or geometric problems to go back and read the question again. When is it more cost effective to rent from Joe's? All we found out is when is it the same? And it's the same after 6 hours. So what I would suggest what we're going to do is it would be helpful to look at a graph. Okay, and sometimes a data chart. So to save some time, I did this graph and we'll show it to you. Here's Sam's rental in the red line. Here's Joe's rental in this bluish purplish line. And we can see when x is 6 hours, the cost is the same. If you would like more information on that, we can also take a look at it as a table. So let's look at it as a table. If x represents the number of hours here, here's the equation for Sam's rental, here's Joe's rental. And clearly I've tried to highlight them in different colors here. $27.50 is less than $40 for the first hour, so Sam's would be cheaper. And at the 6 hours, both costs are the same. And then Joe's would be more cost effective anything over 6 hours. So if you're going 7, 8, 9, 10 hours, that would be the thing to do, is to go with Joe's. If you're renting anything less than 6 hours, Sam's, and if you're going 6 hours, it doesn't matter. And that pretty much concludes our lesson today. Let's just go back and just check again, see what we've got. So again, Sam's moped, Joe's moped, and this is kind of a real life situation. You'll see this, the flat fee plus a rate per unit of time. In this case, it's for hours. And again, looking at the chart, looking at the data, we know to answer the question, it is more cost effective to rent from Joe's greater than 6 hours.